as an exercise for you, although it's not homework, just convert it to the NumPy approach, okay? All right, so let's define the function. Oops. So the function will be, we're just gonna use actually pure Python. All right, so define a function, and we're gonna call it the dot product. Okay, there's one of those math things you see there that needs to be demystified in machine learning. Okay, so we've got A and B. What are A and B? Two vectors. What does that mean? It's like take a Y and another Y, right? And we're going to perform this multiplication, okay? So think the X times the Y, right? You got an X, you got the Y's, you got to learn. So basically we can do something like, I'm going to do this in pieces also. I am going to do a list comprehension. So list comprehension, right? And so, you know, we're going to do a for loop for I in range of the length of one of these, either A or B. Imagine A and B are both a list right now, right? You know, and later on, we'll come back to the equation. I lost the whiteboard because I'm charging the battery. So once I get that back, I'll be able to, but let's start with the code. So for I in range, length of A, length of A. What is this? A and B, do they have the same size for this operation? They need to have the same size for this operation. So we just grab either A or B. It can be, you know, the X's, just think of them as if it's iris data set, how many features do you have? 4. So this should have a size of 4. How many weights do you need? 4. So 4 and 4. You see that? And so we're just going to do this multiplication here. So when we do something like this, then we could just say I, right? So that's a list comprehension. You see that? And then if I just print it, so I'm going to do print list comprehension. Okay, list comprehension. And then over here, then I need my vectors, right? A and B. So let's think of A as, well, actually, let's stick with the example of Satoshi. You know, so I do 2 times 4, comma 4, comma 6, comma 3, right? And then I have B, and that's going to be 1, comma, these would probably be smaller values like the decimals, if they're the weights, but 7, comma 3, comma 2. Do you see that? So the 2 vectors, basically, we're going to, you know, have them there. So I'm going to do that. All right. And then now I'm going to invoke my formula. Oops. Sorry. I'm going to invoke the function. So I'm going to say print. And then I'm going to call in here the dot product. So dot product. Okay. And it's going to take in A and B. You guys see that? And so basically it takes these two. Again, we're doing this idea of like multiplying these vectors, right? We're always doing this, okay? So I'm going to run that. And I got 0, 1, 2, 3. Why is this? No. Where's that none coming from? Oh, there's no return. I'm sorry. Yes, that's right. So return list comprehension. Okay, you guys see that? So basically the function, in this case, all I'm doing is I'm printing them, right? Now what I want to do is I want to multiply each one, right? So I want to multiply this element times this element, then this element times this element. Do you guys see that? Making sense? So I'll write the equation, and then the equation will look like whatever it looks like. But I want you to understand that this is what's happening, really. Okay, so that, and this is the famous dot product, and it's just a multiplication between vectors, a very common operation. Why? Again, video games. have a mesh. I need to move it over there, multiply it times something. That operation in a vector space is a stretching and rotation operation. Boom, you move it efficiently. All right, so now what I'm going to do here is, instead of printing I, what I want to do is I want to multiply the element of A with the corresponding element of B, right? So to do that, I can just say what? A, I, correct? All right, good. Times what? BI, right? BI. You see that? And this is the equivalent of multiplying x1 times, w1, x2 times w2, x3 times w3. You can see there's a common thing there. Those are the weights being multiplied by the x's to obtain the next value of that neuron. Now we need to add them, right? So to add them up, so actually let's run this one here first. So I'm going to do that. It'll work. We don't actually need to print since I'm printing twice. So let's do it. Did it work? So it's 2 times 4 times 18 and 6, right? Yeah, so it's doing the multiplication correctly. Any questions on that part? All right, the next step in this is we need to sum them, okay? So to do that, I'm doing this in parts just so that's more obvious to see. Sorry. Let's do Control copy. Control V. Okay, then Control V. And then I'm gonna sum these values. Now you can see these values are here, right? All I need to do is sum these, right? It's like 2 plus 28 plus 18 plus 6. That's what's happening. So you can simply just do a sum of them here. Because what's really nice about this is we always want to write these functions so that any vector of any size fits, right? We don't want to make it specific for like one thing, because you never know, at any moment you get another data set, boom, you were in Iris, now you're in MNIST, 784 to 4. All right, so now let's try it out. You see that? 54. Make sense? Now, in terms of the equation and the perceptron, we have weights and biases, right? Which are the parameters. So the bias here would be, let's say B equal 3. I'm just making it up here. And then since this, well, okay, I did this outside, right? So then dot product is actually, let's just say result, right? Dot product. And then now to complete that equation that we're kind of familiar with, y, I'm going to do this as a comment, y equal mx plus b, right? It's the line. We're familiar with that, but because it's machine learning and we're predicting something, we usually denote it as w, so wx plus b. You guys see that? So that basically, this w and that x are basically these two, so the dot product. So then all we have to do is, y equal res plus b. Do you see how that works, guys? See how this is important for you to understand that the bias is always, when you have that multiplication, that dot product gives you a value, and then you add the bias to it. It's not like for every input neuron, it's for every output neuron. And then we can print the y. So then we can do like that. Do you see that? Does this make sense? Okay, so this is important. I start with this operation because this is actually at the heart of a lot of neural networks and the perceptron itself that we're going to explore this week. Okay? Again, I stress, this is very important. If you implement this algorithm, because this is a part of a whole algorithm to build a model, right? And if you write it like this with this for loop, let's say that now you're going to use it with MNIST or something even larger, and you start running it, the performance of your algorithm will be affected by that choice. Yes, it's easy and intuitive, but when you're at 3 a.m. in the morning still running this, you're going to wish it wasn't like this. Does that make sense? That's why using it the NumPy way is pretty important, okay? Got it? So for the most part, once we start implementing this in the Perceptron, they will be pure NumPy as the exercises that you guys did at the very beginning of the semester, okay? I can't stress this enough, okay? You know, otherwise it's very slow and people don't want to use it and problematic. Okay, got it? Any questions on this one? Let me just, I want to finish this so I don't have to do it again. So this code is done. Let me just write one last thing and then we'll wrap up the class. I was just waiting for my battery to charge a little. Don't have much, but should be enough. So let me just write this, the equation for this, just so that you're familiar with it. So I'm going to switch over to the whiteboard. Okay. All right, so that should be enough power. So that the corresponding equation to this should be, this is the dot product, right? Dot product. And usually this, you know, it's a method of multiplying two vectors, for instance, in this example. So you can think of it as A, where this is A1, comma, A2, dot, 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 AN of any size. And this is B, and that's going to be B1, B2, dot, 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 Bn. Okay, so basically the definition of the function is, you know, a dot product. It's not a, so in this, there's component wise multiplication and then there's dot product. There's different kinds of multiplications. Okay, so in this case, this is the specific operation which you will sometimes see written as I equal 1 to n of a I, this is I, times b I, okay? Which basically should translate into, which is what we just did, A1 times B1 plus A2 plus B2, or times, sorry, dot, 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 plus AN times BN. Do you guys see that? We just did this in code, okay? I did it the for loop way, because I think it translates way better to this. Just please be aware that's pretty inefficient and it'll be very slow and it will affect your performance. Okay. And so why do we do that? Well, we're going to stop here with just the perceptron, which I want you to see. It's kind of that operation. So remember, this is Rosenblatt. So in this case, the perceptron is your x1, x2, dot, 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 xn, only now these are neurons, right? Neurons that basically, in terms of a neural net, give you one neuron in the next layer, okay? That's that thing that we were getting, res. And basically, we have a multiplication, just like the one we did, where these ones are W1, W2, Wn. You see that? So it's the vector of the weights, the vector of the inputs, that gives you that specific value that we have, right? And so you can think of it as that's that sum that's happening. And then the additional thing is that there will always in neural networks be an activation function. So the result of this goes into this function. Do you guys see that? And we have to study which one Rosenblatt kind of invented for his time. And then you get an output. And then, of course, there's got to be some kind of weight update. You guys see that? So that's what we're going to explore on Thursday. So I'm done with these pages. And then on Thursday, we will just I might do a little bit of a description of the algorithm on the whiteboard, but then we're just going to code this up. And I think this, what's kind of really nice about this is that this method, everything builds on top of everything else. So like knowing the perceptron, 60-70% of a deep learning algorithm already. The simple ones, right? Remember, not the advanced ones like CNNs, transformers, but just deep learning. And you've already done it in Calix. So we're just doing it from scratch a little bit because you do need to understand some of those mechanics. Got it? All right, so I'll pause the video here. Stop sharing and end it.